Okay, so welcome to my session here at Azure Global. Since I'm also moderating this track, I'll have to try to keep track of people joining the session and let them in. But I'll start anyway and try to talk a bit about the whole Azure ecosystem. And the idea is that behind this talk is that the Azure ecosystem continuously grows. There's new services in what feels like every hour, and there is constant development. And so it gets increasingly hard to keep track of what's happening in the ecosystem and what you can do where and use where, especially if you're new to the Azure ecosystem. So I'll try to give an overview of services, what services there are, what services you can use, and what services are good and useful for what. I'll share my screen now. And the first thing I would like to show is what I've prepared here. The idea is that this is not a PowerPoint presentation. I rather try to develop all the ideas and the content interactively and as we go along. So this is the only content that I've prepared so far. So we'll be talking about the Azure Data Platform today. My name is, as you can see, Ben Kettner. I am a proud father of a great 10-year-old daughter. I'm a chapter leader for PAS chapter in Berlin in Germany. So if you ever want to visit Berlin, get in touch and we'll see whether we have a meetup going on while you're there. We're always looking for speakers. I have a PhD in applied mathematics. I've learned to express myself without the excessive use of formulas by now, so I'll try my best to keep that up today. I'm a metal fan, and I'm CTO at MLPA Consulting GmbH. And as CTO at a cloud company, I'm very passionate about cloud and about data in cloud environments. I'm a Microsoft MVP for the data platform, and I'll talk today about giving you an overview of what is available in the Azure Data Platform. So I'll first get rid of all this I'll move it to the side here, and then I'll start drawing a little bit. So let's talk a bit about data first. So we have data. If we're talking about data in the cloud, there's always different kinds of data that we can speak about. There's always, and that was the same on premises, but in the cloud, this has grown a bit more diverse. We have structured data. So data that arrives in a table, in a CSV file and has a fixed structure. And we have what is often called unstructured data. When people talk about unstructured data, what they mean is not data that doesn't have a structure, but usually it is more data that has varying or flexible structure. So often when the word unstructured data is used, what is meant is multi-structured data or data with flexible structures. This can be, for example, JSON files. You can imagine a JSON file has a structure in itself. Multiple JSON files can have the same structure, but the structure of one JSON file to the other can vary. So there can be fields that are present in one JSON file and not in the other without being explicitly set to null. So this is usually what people mean with unstructured data. And of course, there's beyond that, there's also data like image files, video files, the recordings for these sessions that are considered as unstructured data as well. And we have data that is at rest, so data at rest. And we have data that is in motion. And in motion is typically called streaming. So usually those are the different types of data that we encounter in cloud environments. Now, let's talk a bit about what these mean. So structured data, many know, and this is probably the most common data that we know. So structured data is typically stored in SQL databases, so relational data. If we're talking about unstructured data, this is, we could put here, and let's do that, NoSQL. So we use databases that are not only SQL or NoSQL databases. So these are typically structured in documents, in JSON formats or stuff like that. So JSON here, so that this is a reminder of what we're talking about here. But we often hear terms like data lake here. So often unstructured data, when we hear unstructured data, people say, okay, we'll just dump all the data in a data lake and then work with that. We have data at rest, so that is basically data, and that is basically analytics systems, for example. So data that can be used for analytics purposes that we want to query, that we want to work with. And we have data that is in motion, that is streaming data, and that is typically data, for example, from IoT applications or from devices, from logs. And that is typically data that we want to, it's called stream processing. So this is typically data that we need to process as it comes along. So there's a new record, a new message, a new event. So we could also subsumize this as event-driven data. So these are typically the different kinds of data that we will see or that are most common in cloud scenarios. So let's start with the easiest ones. If we're talking about structured data, about relational data, the easiest one here, if you come from a SQL Server background, if you come from a relational background, the easiest thing to do here is use a relational database in the cloud. So you can use something like Azure SQL DB, or you can use a service like Postgres DB for Azure. Or same goes for MySQL and so on. Now, if we're talking unstructured NoSQL, then what we're talking about often, many times, is something like Cosmos DB. And I'm doing something here because I'm trying to exclude services that are not platform services, and that are not services that run on Azure natively, because of course there's millions of relational databases. For example, you could talk about Oracle, but Oracle is not available as native Azure database, but you would have to spin up a virtual machine that you would need to manage. So I'll try to disregard those options in order to limit to services that are actually available as native cloud services on Azure. So if we're talking unstructured data, you have something like Cosmos DB. If we're talking about data lake, there used to be a service called Azure Data Lake. However, that has now been merged into storage accounts. And this may feel a bit strange, but basically a storage account where you enable the hierarchical namespace feature is a data lake because you can dump any kind of file in there and you can order it by the hierarchical structure of your folders. So basically that's why storage accounts turn up here with unstructured data. And this is quite a common scenario if you think about it, because what happens is, for example, if you have streaming data and are streaming data to an IoT hub and you enable the output to storage account, what will happen is that the IoT hub will just take all the messages and just dump all the JSON file, the JSON messages, JSON, put a JSON wrapper around them and store all the JSON objects in a storage account in a directory structure where you have year, month, day, and then files per hour. So usually, so storage accounts are actually a very viable option when we're talking about storing unstructured data. Now, if we're talking about use cases where we have analytics, where we want to work with the data, where we want to process larger amounts of data, then the first service that is native on Azure that we can think of would be Synapse Analytics. And now Synapse Analytics is an interesting service because Synapse Analytics is, of course, we could put all the relational stuff here as well, but Synapse Analytics is an interesting service insofar as that Synapse Analytics is not one service in itself, but more like a suite of services. It's more like a collection of different services that you can use to work with your data. So Synapse Analytics, for example, contains dedicated SQL pools. This is highly parallelized SQL engine that you can use if you want to process large amounts of data. Synapse Analytics also contains serverless SQL pools. And those serverless SQL pools, for example, can be used to create an external table to query data from storage accounts. This is quite a common scenario. So Synapse Analytics sits somewhere in between. So Synapse Analytics also sits in the structured storage, and this is with dedicated SQL pools. It could sit up here, and with serverless SQL pools. Could sit here, and those SQL pools plus, for example, the Data Explorer. ADX, Azure Data Explorer, is a nice tool that is made for analyzing large amounts of log files, for example. That is the base for that contains the Custo query language. That is the base for application insights, log analytics. So Azure Data Explorer is really a cool tool. There's also a Data Explorer pool in Synapse Analytics that enables you to use the ADX, but ADX as a tool itself also is made for analyzing large amounts of data. So we have tools like Azure Data Explorer here. And now another tool that belongs somewhere on the analytics side and that you can use somewhere on the analytics side is Azure Databricks. What is Databricks? Databricks is an external service that is made for working with Spark clusters that basically helps you build wrappers around clusters that run Apache Spark to analyze data. And the interesting thing is Azure Databricks can also do structured streaming. So Databricks is also connected to this somehow. So we can say this is Spark structured streaming. But Databricks can also connect to storage accounts, and Databricks can also connect to relational databases, and Databricks can actually also contain something called Delta Lake that actually also belongs up here. That is basically an engine for large volume data analytics, which belongs in here for unstructured data, but as well up here for structured data. So you can see that the distinction between the different worlds that was quite clear on premises gets more and more distorted in Azure as new services arise that might be used to reach certain goals. Talking about event processing, working with events. When we do that, we have something like stream analytics. Azure Stream Analytics is a great service that enables you to write SQL-like queries to process a stream of data events. So this is also a service that you can use to process your data, but since you already analyze in the stream and partition and distribute to different areas, this is also a very viable solution for working with event data. Another thing that belongs in the streaming and event world is, and we had a session on that already today, Azure Functions. You can think of Azure Functions as code execution as a service. So basically, if you have an Azure function, you deploy code to that function, and there's an event that triggers the execution of that code. And events could be, for example, arriving of a new message on an event hub, on a service bus, on an IoT hub. So, or arrival of a new file in a storage account. So Azure Functions also belong in this event streaming motion of data world. But then if you're talking about analytics and structured data, somewhere here in between, you have something like ADF. We had a cool presentation by Alpa this morning about using Azure Data Factory. Azure Data Factory can with structured data, can work with unstructured data, can put data into those tools, read data from those tools, and ADF can also trigger, for example, Azure Functions. So Azure Functions also belong here. And this bit here I would like to call transformation. And to transform data, there's more tools. For all of these examples that I'm giving you, there's much more tools than what I'm listing here, but these are like in my opinion, in my experience, and from my daily work business, these are like the most important tools that you can use when you work with data. Okay, so now we've listed a whole lot of services, and now I would like to start to go into some of the options that we have with some of these services. I'm sure we will not be able to go into all the services here, but at least give you some ideas of what these services are, how they can be used, what they can do, and what they cannot do, and also introduce some new services that might be interesting in certain use cases. Okay. Let me first start with Azure SQL. We already heard some of that in the previous talk, which was very good about high availability and disaster recovery. Azure SQL comes in several flavors. You have first you have SQL VMs. I said before I don't want to talk about VMs, but SQL VMs are a bit different because SQL VMs are images provided with a pre-installed SQL server and are the easiest way to lift and shift an application to the cloud. They're not the best way because cloud works different than on-premise, and if you're just copying solutions from on-premise to the cloud, you're probably not leveraging the full capabilities of the cloud. However, this is an option that is there and that we see very often for lift and shift scenarios. The second option that we have, and now I start with the SQL virtual machine, where you have to patch the virtual machine, you have to patch the SQL server, you have to work with the SQL server, you have to take care of the operating system, everything. Now, the option where Microsoft says, okay, hang on, we'll take away all this patching of the operating system stuff and patching of the database stuff, but we'll still give you a certain level of access to the server level thing of working with SQL databases. That would be the SQL managed instance. So the managed instance basically takes the power of SQL Server on premises, puts it in the cloud, and gives you the possibility to do things like custom language runtime extensions to your SQL Server, like cross-database joins and queries, stuff that's not possible in cloud scenarios if you do not have access to the server. But that you might need if you want to get your application to the cloud. And now the next thing that you have is like Azure SQL DB. And the Azure SQL database basically is you just provision a database and you don't get access to any of the server features that you might need, that your legacy application might need. So Azure SQL database is like the full-fledged where you don't have to do any work with anything underneath the database, but also you cannot do any work with anything underneath the database. Now let me talk a bit about Azure SQL database, because there are certain different ways of provisioning it. There's a thing called DTUs, data transaction units. This is like a virtual unit that is built to estimate like a trade-off between CPU time and I/O operations and other operations that your database might use. There's pages on the web where you can find how a DTU is calculated, how many DTUs you need for what. But this is one way of provisioning a SQL database. Then there's a way of provisioning vCores. We say, okay, I need a database that runs on 8 cores, and you get a database that runs on 8 cores. And then there's a way of serverless SQL. Now, this might sound strange to have a serverless database, because especially if you deploy a Azure SQL database in serverless SKU, you still have a SQL Server resource in your resource group. However, serverless, and that was stated very often, does not mean that there is no server. It just means that you don't think about the server. The server is managed, is totally managed, also in terms of scalability and in terms of availability, and everything is 100% managed by your cloud provider. So here you basically set the minimum number of vCores and the maximum number of vCores. And then the database takes however many cores it needs in this range and just executes your query. So these are the basic options, and you can go into very, very much detail on any of those options. And for example, if you want to go further into detail on managed instance, I highly recommend listening to a session by Nico Neugebauer, who does great sessions on SQL managed instance. And there's many speakers who will go into very much detail of any of these models. But for now, I think this will suffice for this session. Now, we set storage accounts before on the unstructured side. So let's talk a bit about storage accounts. So a storage account has several services underneath. A storage account has a blob service. It has a table service. And it has a queue service. What do those mean? Blob service, basically, there's also a file share service, but we'll not talk about Azure files now, and let's just keep to the basics here. So basically, this is where you can store blobs, so binary objects, so files. So table storage, basically table storage is like a database. You get a table where you can store data. So it's a table, but it's not relational because you cannot build foreign key constraints or anything. So it's just one single table that lives isolated. You can have multiple single isolated table, but it's just an isolated table. You can think of it like a CSV file together with an API to get the data out of that CSV file. And I'll talk a bit about where those tables will be used later. And you have a queue service, and basically the queue service is just you have a queue where you can add an item into a queue and then work with that item at later points. So that's just what the name says. You have a queue for items. Okay. Now we've covered those services. Let's talk a bit more about Azure Functions and Azure Data Factory. So let's talk first about Azure Data Factory. Because this is also kind of interesting, I think. So Azure Data Factory consists of linked services, of data sources and sinks, which are also called data sources, and of pipelines. And a pipeline is used to copy data from a source on a linked service to a sink on a linked service. But not only that, even transform some data or execute some stored procedures in a database or list the files in a blob container. Things like that can be done in pipelines through data services and linked services. Data sources and linked services. So that's how Data Factory basically, and put that here because I think this is important, is basically this part here is an orchestration. So if you say, okay, I want to copy data from a source to a sink at a certain time each day, and if copying the first file to the database succeeds, then I want to copy the second file. If not, I want to retry. If that fails again, I want to copy from a different source. Stuff like that, orchestration of data movement, of data transformations, of calling certain services. So this is Azure Data Factory in one way it works. But Azure Data Factory has more than that. Azure Data Factory also has data flows. And basically, data flows in Azure Data Factory are a visual representation of a Spark process used to process data. So here you can think of you get data, and for each row you look up a certain value from another data source, or you filter the data by certain mechanisms, and you add certain metadata. Stuff like that happens in data flows. So this is the other thing that's not really the orchestration part, but that's like more of a processing part, data processing part, and data enrichment part, and also sometimes an analytics part. So this is the second side of Azure Data Factory. And Azure Data Factory plays one of its strengths when interacting with other Azure services. So another Azure service that Data Factory interacts with often are Azure Functions. And I said before that Azure Functions can be seen as code execution as a service. Put that here because I think that's important. So you have some code that you want executed whenever an HTTP endpoint is called, that you want executed whenever a message is retrieved in some messaging mechanism, whenever a new file is placed in the blob. So the important thing is Azure Functions have triggers that trigger the execution. They have bindings, output and input bindings that you can use to connect to different services from your code. And they also come in different flavors. So the flavors in which they come are you can provision an Azure function on an app service plan. Meaning you say, okay, this Azure function to execute will need so many CPUs, so much RAM, and I create an app service plan that has these properties, and then I deploy my Azure function onto that app service plan, and it's executed on that app service plan. Now, if your Azure function, if you have lots of load on your application, your Azure function needs more CPU, you'll have to scale up or scale down that app service plan. And that's not the very cloud way of doing things. So the cloud way of doing things would actually be the second SKU that Azure Functions have, and that's the consumption plan. And the consumption plan is a serverless plan, meaning, as before, serverless doesn't mean there's no service involved, but we do not care about those servers. I'll talk a bit about that in a moment. And the third plan that we have is the premium plan. That is also a serverless plan like the consumption plan. However, the premium plan has some additional features. For example, you can have warm standbys. Consumption plans only have cold standbys. The premium plan offers private endpoints if you need these. So there's a few differences, but let's concentrate on the consumption plan now. The great thing about the consumption plan is you just pay for the times your function is executed and not for times where it's up, where the app service might be idling. So if you have very uneven loads, like you have peak times when your application is used or when you load your data into a data warehouse or something like that, if you have peak times of consumption, then using a consumption plan is a good idea because you won't pay between those peaks. And the second thing that happens, and other than for the SQL database where we said for the serverless tier you have to give a min and a max vCores, you don't do that for Azure Functions. They just scale. And they scale not by scaling up the instances on which they're running, but by scaling out. Meaning, if the first instance of your function reaches a certain load, a certain number of executions, a certain CPU load, memory pressure, anything like that, then a second instance is spawned. And when that reaches a certain load, then third instance is spawned. And if the load goes down, then the third instance is deleted and there's only two instances left. And all of this is done automatically under the hood by Microsoft, by Azure. So that's a great thing if you have varying loads on your application. So that's basically how serverless Azure Functions work. However, there's one thing that might be a bit difficult. If you think about things like applications that, for example, you have a visit counter, then that visit counter is typically stored in the state of an application or in a database, meaning that your function or your application would need to access the database each time it is called, or it has a cache state where it stores this information and updates that cache, that state, and then returns that. The tricky thing is that you don't know, if you're in a consumption plan, whether the instance you talked with on your first visit still exists when you do your second visit. So they're, by definition, Azure Functions are stateless. And to get state into Azure Functions, we need durable entities. Durable entities are basically the function framework's way to handle state. And now this is where it gets interesting. Durable entities are typically stored by default in a storage account table. So here, your Azure Function Framework creates a table to store its durable entities. It serializes them to a JSON format and puts them in a column of your Azure table. So here I'll put durable entities. Okay, so that's how these two interplay. But you can also, durable entities can also be stored in a SQL database. That's a new storage backend. I think it's still in preview. I'm not sure. I've not tried it yet because this has some consequences regarding logging, regarding connection limits, stuff like that. So this is also a possibility. Okay, and what can you do if you have a data factory pipeline that needs to access a resource that might be difficult to access, that might take some time? Of course, you can call from an activity from a pipeline. You can call an Azure function to process your data. That's one option. Or, and that's also a very nice option, how these can interplay, you can place a message in a storage account queue, and that message can then trigger an Azure function. So you see all those services interact in certain ways, can interact in certain ways, and it's important to understand how these individual services work and how they work together. This is something that's really important. I'll just pull up the. Okay, I thought there was a message because I heard some plings, but there's no messages, so we're fine. We'll just continue. We have another 20 minutes, and I plan on filling them, talking a bit more about data streaming, about processing data that's not at rest. So far, most of this was data at rest. Now, let's talk a bit about data that's not at rest. Let's talk about a typical IoT application. If we talk about a typical IoT application, what we have is usually we have some kind of device. So an IoT device, expertly drawn, that sends data, and one of the standard formats for sending IoT data is MQTT protocol. Now, it sends this data to an endpoint in the cloud, and the endpoint in the cloud here in Azure is our Azure IoT Hub. Okay, so Azure IoT Hub has some unique features. For example, Azure IoT Hub can talk back to devices. It's bidirectional. It handles authentication of the devices, authorization, stuff like that. So IoT Hub is a useful tool that happens in almost any IoT application that I am aware of. Now, there's still plinging going on. This is somehow kind of irritating. I don't know where it comes from, but never mind. Okay, so IoT Hub is a useful tool that is part of many IoT applications, as I would say most or all IoT applications. Okay, so now we have a message in the IoT Hub. This message is in the format of your device and might need to be mapped to some internal data formats. So basically what we want to do is from the IoT Hub, we'd like to get to some database and maybe even a storage account. Or not, let's not put storage account here. Let's put some data lake. And database. Okay, so now how do we get data from here to those? Well, there is a possibility to write directly from the IoT Hub to a storage account to store all the messages. IoT Hub has that capability. However, that means you're stuck with the format in which and the structure in which IoT Hub writes the data. What else can we do? We can add something here like Azure Stream Analytics. And as I said, Stream Analytics uses a SQL dialect to process the data that comes in here. So Stream Analytics has the possibility to send certain data to your database, send other data to another database, has the option to trigger an Azure function, or to store data in a data lake or in a storage account. So this is one option in which you can do it. However, there's also other options. For example, you could say, okay, if I don't need the SQL dialect, but I need more flexibility as to how to process the data, you could also use, as an alternative, use an Azure function here. So that would be the second option that you would have, to have an Azure function here that processes your streaming data, enriches it, puts it into a database. That Azure function could then use durable entities. Could use a durable entity to map the IoT hub device name that is unique to the device in the field, and take that and map it to an internal device ID that you might want to work with when having your data in the database. So those are our typical processes that you have here. And now, of course, you have an issue if you have this function. What happens if you have this function and assume that this database here is down for some reason? This database cannot react. This database is getting slow. Then this function would be slow in processing the requests, which would mean we would scale up and up and up because the functions run longer and longer, they accumulate cost, and at some point they fail. And then we have messages sitting here that were not processed and that might still, and now I'll put something else here. Let's say we have an alarming system, an alerting system here that needs to alert your customer in case of emergencies. Okay. And let's assume you have an alerting system in place, and a message that's not processed here due to the unavailability of a database will not trigger an alert. So what would we typically do? We typically add some kind of queue here in between. And from that queue, we would read here, not have this, but read here from the queue and read here from the queue to write to the database. So that way, if the database is down, this process will stand, but this process will still work and we'll still get all our alerts. Now let's talk a bit about this queue here. What can we use as queues? Whoops, that's not what I wanted. Hang on. I didn't want that. I wanted that. So what can we use as queues? So this one here, what can we use here? So the first thing we've already seen is storage queues. Their advantages, they're cheap. They cost next to nothing, and you have plenty of them in your subscription, as you will most likely have several storage accounts, and each of these storage accounts, if you've not disabled them, has this, the queuing, the queues service. So you have several of these. They're really cheap. However, they're, in terms of queues, they do not guarantee at least once delivery. They have certain limitations to how you can access them, how you can read of them. So if it's very simple things like fanning out a function by adding stuff to queues and then calling other functions with queue triggers, these work fine. But if it's in terms of for alerting or anything, then those might not be the best ideas. So what else do we have? In Azure, if we're talking about data services that can enable queuing, we have event hubs. And Azure Event Hubs, for example, guarantee at least once delivery. They have things like features like, uh, I'll add that in this color here, like partitions. And they have features like um, uh, partitions and consumer groups. So basically, partitions define scaling, but what consumer groups do, consumer groups are more interesting because you have your event up here and you have messages going in and you have an event up here and you have several partitions where those messages are queued. Okay. And then you have a consumer group and a second consumer group. And those read from all partitions. And then you have somebody reading from here. And each consumer group has one consumer, say, for example, an Azure function. And now if this Azure function is down, the messages read by this function here will not affect what this function can receive once it started again because it has its own consumer group. So you can think of a consumer group like a pointer to the message that was last delivered. And like if you have several consumer groups, then each consumer group is a pointer to the message that was last read. So you have this function, and this has a pointer to the third message, and this function that has been down might have a pointer to the first message. Now the fourth message arrives, and this one will be reading it because it has a pointer to the third message, but this one still has a pointer to the first message. Now, if this function gets up again and the consumer group is here, then it will know the last message I received was the first message, and then it will receive the second, the third, and the fourth. So basically, consumer groups enable you to have different consumers on your event hub that read the data at different speeds or process the data at different speeds. And this is a really important feature that, for example, storage queues don't have. And the next service that we can talk about when we're talking about queues is Azure Service Bus. And Azure Service Bus is similar to Event Hubs. There's a few differences between the two. Event Hubs are very much tuned to throughput. So they're designed for having very high throughput. They have Kafka endpoints and are designed to deliver thousands of messages. Service Bus, on the other hand, has a higher server level agreement in terms of Service Bus guarantees that message 2 will never be delivered before message 1. Event hubs, this can happen. Events can arrive out of order. Service Bus guarantees the order of your messages. This might make a huge difference if you have like messages, think about messages for a shopping cart. Add item to shopping cart, remove item from shopping cart. If I get the remove item from shopping cart message before I added an item to the shopping cart, nothing will happen. And then I have a message saying add item to shopping cart, and I'll have it in the shopping cart. If they arrive in the other order, then I won't have an item in the shopping cart. So the order of events is really important. And in that case, if the order of events is important to your application, Service Bus is the way to go. Otherwise, you can go with event hubs. And there you need to also consider, like, for example, if we go back to our IoT scenario that we had here, in our IoT scenario, messages might already be out of order here because your device might be down, your device might be sending at irregular intervals, certain messages might not be delivered due to network issues on the device side. So you might not have event ordering given in an IoT application anyway. So you need to think about what does my application require and what does my application deliver, which part of my application delivers what. So these were the queuing mechanisms. And now I would like to go a bit more. We have 8 minutes left, and since There have been no interruptions or questions. I'll just go on till the end of my of this presentation time is reached, and I'll just continue talking. So let's talk a bit about analytics. We've talked about databases. We've talked about Synapse. We've talked about Databricks. I would like to include on the analytics side of data also analysis services. And I would also like to include on the analytics side of data, I would also like to include Power BI, because more analytics than we all think happens in Power BI. Due to its modeling capabilities, which are closely related to analysis services or the analysis services tabular engine. And I would like to include in the discussions for the last 5 minutes of this presentation for the analytics side of things also the Azure ML, so Azure Machine Learning Services. So we already discussed Synapse Analytics as having pools. And another service that we definitely need to mention here is ADX, Azure Data Explorer. We already mentioned that before as well, but this is also very important. We mentioned that Synapse Analytics has pools, so it has different engines underneath for different services. So let's say, and this is something, let's think about these as engines. So you could say, okay, serverless SQL serverless pool is like an engine that is able to execute SQL but doesn't have a server and doesn't have its own storage. A SQL dedicated pool is like an engine that is able to execute SQL on a dedicated hardware, so it has its own storage and has its own data. And Data Explorer pool is like the engine of Data Explorer that you can use so that you can use Custo queries in Synapse. Spark pool is like an engine that is able to execute Spark code. We talked about Databricks. Databricks is like a hybrid, I wouldn't say, but a bit different than other Azure services, because Databricks is a third-party solution. And what you do if you create Azure Databricks, you first create an Azure Databricks workspace. And in that workspace, so I'll put workspace here because this is important. And in that workspace, you need clusters. And those clusters are managed by Databricks. So what will happen if you create a Databricks workspace is a second resource group, a managed resource group is created that contains those clusters, that contains a storage account for your Databricks file system that is shared between the different cluster nodes, that contains a network infrastructure for those clusters. All of that is managed by Databricks and is created by Databricks and is worked by Databricks. There's one thing I can warn you about if you use Databricks for streaming. Be careful about the Databricks file system, about that storage account. This can amass quite a lot of cost due to it being geo redundant by default. And it's a good idea if you're using a development environment to create that as locally redundant so you can avoid extra costs, and start with small clusters, not start with an 8-node cluster for development. Start with a 1-node cluster that reduces data transfer and reduces cost for data transfer. So that's usually a good idea. Databricks, you can write notebooks in Python or in Scala, typically, depending on what your application is. Python it might be better, or Scala might be better for streaming. I've tended to go to Scala, even though I prefer writing Python code. So it depends. Analysis services, basically Azure Analysis Services is the tabular analysis services that you might know from on-premises applications. So this enables you to do lift and shift, to do the stuff you do in analysis services if you want to analyze data with Excel, for example. Power BI would be a session in itself. I only put that here because actually the data modeling capabilities of Power BI are related to analysis services. The engine is related to analysis services, and it is used very often. And the great thing is Power BI, for example, can connect seamlessly to Synapse, can connect to analysis services, can connect to databases, can connect to ADX. So you have several ways to connect Power BI to other services. Azure ML has a graphical user interface for creating machine learning solutions. And the great thing is not the graphical user interface. Depends on your know-how before starting to work with it, whether you like that or not. But the great thing is it offers you the possibility to create services, for example, REST services from your model. So you've trained a model, and Azure ML gives you the possibility to create a REST service from that model and add that to any pipeline. So this is quite a nice option if you want to include machine learning stuff into any pipeline, be it a streaming pipeline or be it a data factory pipeline, and you want to pipe data through a trained model, then for example, you can use the REST service, the REST endpoints that you can create in Azure ML to integrate your machine learning into any other process. Data Explorer is, again, a session in itself. The important thing is it uses the Cousteau query language, so a new query language. This is a cool language. It's highly scalable, ADX. And the most important thing about ADX might be it was developed internally by Microsoft for working with log files, so it's very suited for working with time series data. And it really excels at analyzing large volumes of time series data. And that's a really nice thing about Azure Data Explorer. But as I said, most of these services are sessions in their own or conferences in their own right. But the goal of this session was to give you an overview of what you can do in Azure and what services you can do in Azure. Now, if we zoom out a little bit and look at what we've covered in this session, and that will be the final thing I want to say here, we've covered like an idea of what service can do what. We've talked a bit about how to deal with data at rest, how to deal with relational data, how to process data at rest, how to process data dynamically, how to process data in a serverless manner. About storage accounts, we've talked about architectures for working with streaming data, and we talked about tools that you can use for the analytics part of any data application in Azure. So I hope that you find this overview helpful, and this is an overview that you can refer to in future use cases, that this is something that is of value to you. And I thank you for watching my presentation, and I hope you have a great day. Thank you and goodbye.